Good morning, everyone. Today we're going to be working on section 6.3, which is confidence intervals for population proportions. A lot of the steps we'll be taking to construct our confidence intervals are very similar to the steps we took in 6.1 and 6.2, but the formulas differ just a little bit. Okay, so you guys are going to learn how to find a point estimate, which we already know. Point estimate is kind of an estimate of the mean using some information that we already have provided to us. For the population proportion, we're going to construct and interpret confidence intervals, just like we have been doing. That's the common theme here. And we're going to determine the minimum sample size. So this is actually going to be tomorrow's lesson. We're not going to get to that today. All right, let's talk about the population proportion. As you recall, a binomial experiment is an experiment where we can have two outcomes. It's either a success or a failure. So a binomial experiment might be the probability of flipping a heads. Okay, you either flip the heads or you don't. Okay, it's denoted by P, and we'll just put here two possible outcomes. Success or failure. It's denoted by P, okay? Now we can calculate the point estimate for P, and the point estimate for P would be the population proportion of successes in a sample, okay? So again, kind of just like we were doing that point estimate for a confidence interval for a population mean. It was the mean of the sample. This is going to be the population proportion of successes in just a sample. Now, this phrase sounds kind of crazy and intimidating, but it's really not that bad. The population proportion is denoted by this little P with a, I guess, kind of arrow on top of it, and it's read as P hat. And the way that you calculate that is X over N, where X is the number of successes and N would be the sample size as usual. Okay, so it's really just a fraction you're setting up in order to calculate this point estimate, and we're going to be using it throughout the lesson today. Okay, so as you go through your notes, you'll see that there are examples and there are tries. We're going to do the examples together, and you're going to do the tries for your homework. And you're going to take pictures of it and submit that as your grade for today. All right, so first example. In a survey of 1,000 U.S. adults, let me get some highlight going here, 1,000 U.S. adults, 662 say that it's acceptable to check personal email while at work. Find a population estimate for the population, find a point estimate for the population proportion of U.S. adults who think it is acceptable to check their personal email while at work. Well, we need two things. We need our N value, which is our sample size of 100. We need our number of successes, and in this case, it would be people who say it is acceptable. So that would be 662. P hat is equal to X over N, which is 662 over 1,000. Which is 0.662 or 66.2% would be our answer. Okay, so pretty simple. You're just going to set up X over N, and that gives you your point estimate for your population proportion. All right, first homework problem is going to be this one right here. Try number 1. Okay. So the point estimate for the population proportion of failures is denoted as Q hat, and it's just 1 minus P hat. But if you're going to do 1 minus P hat, you need to make sure that P hat is in decimal form. Okay, because if you tried to do 1 minus, what was our last one, 66.2, that wouldn't make any sense at all. Okay, so make sure that your P hat is in decimal form when you are figuring out your proportion of failures. So here's our next example. In a survey of 2,462 teachers, 123 said that all or almost all the information they find using search engines is accurate or trusty. So the total number is 2,462. and the number of successes is going to be 123, because 123 said that they find acceptable or trustworthy information. Almost all or all of the time. So in order to find p hat, we're going to set up 123 over 2462, which gives us, if we plug that directly into our calculator, 0.05. So that means q hat is just going to be 1 minus 0.05, which is 0.95, or about 95%. Okay? All right, so that's finding the point estimate for q hat. Next one is going to be your second homework problem. All right, so now constructing confidence intervals. And like I said before, a lot of the steps are going to be the exact same as what we've been doing with our confidence intervals, but the formulas might be a little bit different. So as you can see, our formula for E is a little bit different. It's our critical value for our confidence level times the square root of p hat times q hat all over n. Okay, and ZC is still that critical value. Here's just another little chart of your common confidence levels. I don't think there's any today where you have to use a confidence level that's not common, but remember, if not common, you can use the inverse normal function on your calculator to find the critical value. So you would use inverse normal, and then the area is going to be 1 minus the confidence level over 2, comma 0, comma 1. So for example, if we needed the critical score for 80%, I would do the inverse normal of 1 minus 0.8 over 2, comma 0, comma 1, and that gives me 1.28. And remember, you always use the positive z-score, because if you put that in the calculator, it would technically give you negative, but you always use the positive in these formulas. Okay, so the key takeaway here is we've got this formula now for E, and that's going to be our formula, and then we're going to just continue with our population proportion confidence intervals like we've been writing our other confidence intervals. Okay, so here are the steps to construct our confidence interval, and again, they're going to look very similar. You first identify your sample statistics N and X, so you have the sample size and the number of successes. Then you find p hat and q hat, using p hat with our little formula, q hat, just as a reminder, I'll write it down. Q hat is 1 minus p hat. Find the critical value z that p hat corresponds to. So that's either going to be one of the common ones, or you're going to have to use that formula I gave you using the inverse normal function. Oh, excuse me, I'm tired this morning. Number 4, you find the margin of error E using that new formula we have for margin of error. And then our confidence interval, the left endpoint is going to be p hat minus E, and the right endpoint is going to be p hat plus E, and then we interpret like we normally do. So let's take care of our first example. Now, the first example, I'm going to write out all the steps. You don't have to do that for your homework problems, but I'm just going to write them out so we are used to seeing how it's done. Okay, so first let's highlight our pertinent information. So in a survey of 1,000 U.S. adults, 662 said that it is acceptable to check personal email while at work. Okay, and then we need to do a 95% confidence interval. So let's go step by step here. So step 1 was to identify your sample statistics N and X. So N would be 1,000 and X is 662. Step 2 is to calculate p hat and q hat. P hat is 662 over 1,000. And another thing that I didn't note before, p hat and q hat are always going to be less than 1 because it's a percentage, it's a portion of the total. So it's saying like, what's the probability that this many people say yes, and probabilities have to be less than 1. So just make sure you always check that your p hat and q hat are less than 1. If they're not, it means you probably just have the equation upside down. Okay, p hat, q hat. We've got 0.662 and 0.338. So next we're going to use our confidence level of 95%. And that gives us a critical value that's a common one, so you could just use your chart of 1.96. Step 4, we calculate E. And remember, that is your critical value times all of this stuff goes under the square root. P hat times q hat all over n. I made that really big. Okay, so we've got 1.96, and then p hat is 0.662, q hat is 0.338 divided by 1,000, and all of that stuff goes under the square root, and our E ends up being, when we plug that in the calculator, 0.029. So next we construct our confidence interval. So my left endpoint is going to be p hat minus E. My right endpoint is going to be p hat plus E. So we get 0.662 minus 0.029, 0.662 plus 0.029, and we get 0.633 for the left endpoint, 0.691 for the right endpoint. Okay, so now we draw our diagram and we interpret. Okay, so final product, draw your diagram and interpret. So we've got our beautiful number line here. So my left endpoint is 0.633, my right is 0.691, so we'll do 0.63, 4, 5, 6, 7, 8, 9. Okay, so we've got 0.630, 0.640. You know what, I'm going to do these sideways. Oops. So I can fit them. Okay. So what did I say we were starting with? 0.630, 0.64, 65, 66, 67, 68, 69. Okay, and then just like always, we put a point on our point estimate. In this case, it would be our little p hat. So we're going to put a point on 0.662, which would probably be somewhere around here. Okay, we put a left parenthesis on our left endpoint, so 0.633. We put a right parenthesis in our right endpoint, 0.691. And then we just darken up the interval in between to show that it's somewhere in here. Okay, and now our favorite part, the interpretation, because I know we all love that so much. You guys need to stop being lazy with the interpretation, because on graded assignments, I will mark it wrong. Okay, so stop being lazy. I know it's a lot to write, but you have to write it out. Okay, I don't care if you shorten words, but you can't shorten the actual interpretation part. All right, let's get to it. So, with 95% confidence, we can say that the population proportion of, And this is where we're struggling a little bit. You guys have to go back and you have to read the context of the problem. So I kind of highlighted that in blue for you to see a little bit better. It says, U.S. adults who think that it is acceptable to check personal email while at work. That's what goes here. So with 95% confidence, we can say that the population proportion of U.S. adults who think it is acceptable to check personal email at work is between, it would be, what was it, 63.3% and 69.1%. Okay, that's what it needs to look like every time. I know we're a little bit lazy and we don't want to do that, but you have to write it out like that. That is an acceptable interpretation. Okay? All right. So we've got one more example that I'm going to do here, and then there's one on your last page of notes that we're going to do. And then you guys are doing the try problems. If you want to pause the video, try example 4 on your own, and then check your work. You're more than welcome to do that, but I'm just going to walk through one more for those that need it. All right, here's our next example. In a survey of 674 U.S. males age 18 to 64, so let's kind of highlight some information here. So 674, 396 say, and then our population here is U.S. males age 18 to 64 have gone to the dentist in the past year. And then we're constructing a 95% confidence interval. All right, so let's write down all of our key info. So N is 674. Whoops. X is 396. P hat is 396 over 674, which is about 0.588. Q hat is 1 minus P hat, which is 0.412. Our C is 90%, so that's a common one. So our critical value is 1.645. Okay. Now we can calculate E, which is our critical value, times P hat times Q hat all over N, and then that stuff all goes under the square root, and E is about 0.031, and that's good. We always want E to be a decimal less than 1. So then we have P hat minus E, which is 0.557. That's our left endpoint. P hat plus E is 0.619. That would be our right endpoint. So I'm going to, actually I ran out of room, so I'm going to do this above the problem because I can make a little bit more room up here. So now we construct our interval. Whoops. And we need to go from 0.557 to 0.619. So I'm just going to start at 0.56 and go by hundredths. So 56, 57, 58, 59, 6, 61. I need a little bit more room. And 62. .61, 60, 59, 58, 57, and 56. Okay, so that should be good. Now let's plot our point estimate. So our point estimate would be p hat, which is 0.588. So 0.588 is going to go somewhere around here. And then we're going to plot our left endpoint, which is 0.557. So that goes just before 0.56. And then our right endpoint is 0.619, so that goes just before 0.62. We're going to darken it up. So we'll just go back over here, back over here. I'll make my point a little bit bigger. And now, time to interpret. Okay, so again, please model your interpretations the exact same way every time. All right, so we're going to start off with 90% confidence. We can say that the population proportion of U.S. males 18 to 64 that have gone to the dentist in the past year is between 55.7% and 61.9%. Okay? All right, so your next two problems are your next two homework problems. They are both tries. Okay, so we've got try number 3, try number 4. I have one more example to do on the last page of your notes, and then you have 2 more homework problems. All right, so you actually have one more try here. We've got try 5 as well. And we're going to do example 6 together. It's similar, but it just gives us a picture instead of giving us the X, and you'll see that when we read through it. Okay, so the figure below is from a survey of 498 U.S. adults. Construct a 99% confidence interval for the population proportion of U.S. adults who believe teenagers are the more dangerous drivers, okay? So you'll notice they don't give us our X value here, okay? They don't give us that. They don't tell us exactly how many U.S. adults there are that think that teens are more dangerous, but if you look at the picture right here, teenagers 71%. Now remember, P hat is the percentage of successes. So in this case, we don't need our X value because they already give us P hat. So our N is 498. P hat is 0.71. Q hat is 1 minus that, which gives us 0.29. Our confidence level is 0.99, which means our critical value is 2.575. Again, that's a common one. We can calculate our E, which is going to be 2.575 times the square root of 0.71 times 0.29 all over 498. I don't know why I put 88 up here. Oops. Okay, and that gives us about 0.026. We have our left endpoint. We have our right endpoint. Our left endpoint is 0.684, P hat plus or minus E, and then P hat plus E is 0.736. Okay, so we can construct it. I need to go from 0.684 to 0.736, so I'm going to start with 0.68 and go to 0.74. 68, 69, 7, 71, 72, 73, 74. Okay, I had room for an extra one. So this is 0.680, 0.69, 0.7, 0.71, 0.72, 0.73, 0.74. Okay. All right, so now we're going to put a dot on p hat, which is 0.71 right there. We're going to put a parenthesis on 0.684, which would probably be somewhere around here, halfway between 0.68 and 0.69. And then we're going to put a right parenthesis on 0.736, which is about here, about halfway between 0.73 and 0.74. Darken it up. Okay, and then we write our interpretation with 99% confidence. We can say that the population proportion for U.S. adults who think teens are more dangerous drivers is between, and then we've got 68.4% and 73.6%. Okay, and then you've got your last example for homework, or your last homework problem, which is try number 6. So altogether, you guys have 6 homework problems. If you have any questions, as always, you can comment directly on this post, or you can reach out to me. I did extend the due date for Math Lab. I know some people are having a hard time. You got to try to access it during the day. At night is when they're doing their maintenance. It's being really screwy. It's in and out. It was in and out for me last night as well. So try to get on Math Lab during the day. That due date is going to be Sunday now. And don't forget to continue working on your project. If you have any questions, just shoot me an email. Let me know. Have a good day.